We are going to cover complete VoLTE protocol stack so that you can understand VoLTE end to end. Protocol is most important thing which enables communication in telecom world. Entire LTE and VoLTE network is based on three key protocols. The first one is the diameter, the second one is the GTP, and the third one is SIP. We are going to discuss VoLTE Control Plane and User Plane protocols. Similarly, since 4G works closely with VoLTE, we are also going to cover LTE 4G protocols here. Here I am going to provide complete VoLTE protocol guide which contains detail of all links and interfaces working in VoLTE and LTE networks. VoLTE network consists of three network domains. The first one is the LTE network, handling the user, followed by the VoLTE network, and finally interconnectivity with the PSTN or CS network. Since LTE or 4G network is an essential part of basic working of VoLTE IMS network, I have also included LTE interfaces, links and protocols in this video to make it more comprehensive in order to give you a complete knowledge. A protocol is a system of digital rules for message exchange between the telecom nodes in order to communicate with each other. As visible in the diagram, this is a protocol stack design which shows all the communication layers of LTE and VoLTE network. Three lower layer stack consist of the first one as the physical layer, followed by the MAC or data link layer, and then the IP layer. From here onwards, all communication for LTE and VoLTE is taken care by the UDP and SCTP protocol, which are again and again used in the network for multiple purposes. On top of UDP and SCTP layer, we run various LTE and VoLTE user and control plane links. Most critical links are the real-time transfer protocol, which is RTP, diameter, session initiation protocol, which is SIP, and the last one is the session description protocol, which is also called as SDP. Let's discuss two fundamental low layer protocols used in LTE and VoLTE. The first one is the SCTP, which stands for Stream Control Transmission Protocol. This evolved from TCP. SCTP is used to provide guaranteed message delivery. SCTP is extensively used for transport layer for carrying the telecom signaling over IP. SCTP provides a reliable transport service so that it can operate at a message level. SCTP also allows multiple message streams to be exchanged on a single SCTP connection. Net, where you need the reliability, you have to use SCTP down the line. This is a connection oriented protocol which is much more similar to TCP, gives you all the benefit of TCP in order of reliability, retransmission, handling errors. This is much robust protocol which gives you better performance and redundancy. The couple of links runs on SCTP, which are S1 AP, X2 AP, diameter, S6, GX, GY, so many of them. This is mostly used in LTE or 4G network. This is best suited for control plane and typically used in a closed reliable network within a particular network and used for various purposes such as billing, charging, authentications. The next one is the UDP. UDP stands for User Datagram Protocol. I believe you know this protocol. There is no point of discussing it in depth. This is typically used in a non-reliable media communication where multiple operators are involved or like a long distance media is involved, like such as a communication between two operators on roaming, or it may be used between the MME and the S gateway, and maybe the S gateway and the P gateway. This is typically suited for a non-reliable media. It doesn't guarantee that data will be received in the order it has been sent. It is a minimal message oriented transport layer protocol. The typical example of usage in our LTE and VoLTE domain is the S1U, GTP1U. The control plane includes GTP-V2C, which is used in S5 and S8 links. So this is best suited for a long distance and open networks. Now, here is the actual list of protocols we are going to cover for LTE user plane and control plane. Similarly, this is a second table which gives you the VoLTE IMS interfaces which we are going to cover as part of this tutorial, which will give you end-to-end knowledge on all these links. On left hand side we can see the LTE network on a high level and its component. On right hand side we can see the VoLTE IMS network and its component. As you can see in the blue circle, I have grouped few functions in IMS. ICSCF and SCSCF are typically deployed within the same server, within the same rack, within the same chassis, and they are shown as one node. SBC consists of many critical functions such as PCSCF, ATCF, AT gateway, IBCF, TR gateway. They are shown together. Similarly, the media gateway consists of MGCF and IM media gateway. They are also grouped and shown as one node. Here HSS, OCS and PCRF are three main components which are used by both LTE network and VoLTE network for interconnectivity. Let's see high level protocols used in the network. This is all blue links connecting each other, which works on SIP protocol. You can see all SIP to SIP to SIP communication in the entire VoLTE ecosystem. SIP is the chief protocol which is used for carrying the voice calls, which carries the voice call over IP without any limitations. On left hand side you can see the yellow connectivity consists of diameter links which are widely used for control plane signaling, billing, charging, authentication in LTE and IMS networks. Now before starting our journey with the links, I would like to give you a quick introduction on the SIP and diameter so that you understand it fundamentally how it works. SIP stands for Session Initiation Protocol. This is a communication protocol that is widely used for managing multimedia connection sessions. Multimedia means you need to carry the voice, the video and the multimedia calls. SIP therefore is one of the most specific protocol which enable voice communication over IP. In a VoLTE call, SIP protocol is used to create, modify, terminate session. Essentially, it also used for negotiating the codecs between two users. SIP doesn't perform the transport layer. I mean to say it's not used for carrying and delivering the data or voice. These are done by RTP and RTCP. SIP manages the entire control plane of the call so that RTP can work properly. Now let's understand diameter, which is widely used in 4G network. It's also widely used in the VoLTE IMS network. It's used for authentication, authorization and accounting. This evolved from the earlier old radius protocol. This is an enhancement to radius basically. It's an evolution to radius AAA protocol which gives you much more reliable and secure communications, which supports the failover mechanism to maintain the redundancy. I mean to say, if primary link goes down, the traffic will fail over to the secondary link. These type of redundancies and failover mechanisms are provided by the diameter inherently. Diameter also supports proxy and relay agents. It also supports a flexible AVP option where we can give a mandatory and optional list of the parameters or AVP which can be used in the capability negotiation. Now let's start our journey with the base LTE network. You can see the basic network here, which consists of a E node B equivalent to the cell site providing the radio coverage. MME is used for control plane traffic and handling the mobility of a user. S gateway, P gateway is also called as Psi gateway, used for handling the user traffic, and it is used for a breakout towards the internet and IMS network over the IP links. The key interfaces of a LTE control includes the S1 MME, S5, S8, S10, S11, S6A, GX, GY, X2, SGS. Similarly, for user plane, we can see the links as S1U, S5, S8 and SGI links. I'm going to quickly wrap up the LTE links so that we can spend much more time on the VoLTE IMS links and the interfaces. S6 links connect MME to HSS. This is a diameter link and is used by MME for checking the subscription and authentication data for the authenticating and authorizing the user access from the HSS. In simple words, MME download the user profile from HSS with the help of S6 links. The profile data will be something like APN, which may be allowed or not. A data could be like whether user can use the internet services or not, whether user can use the IMS VoLTE services or not, whether these services are allowed on roaming or not. All these type of profile information is downloaded by HSS to the MME with help of this S6 link. GX interface is between the PCRF and P gateway. This is also a diameter link allowing a PCRF to take direct control over the policy enforcement functions of the P gateway. This is used for QoS management. In simple words, GX link is used for enforcing the speed of users. For example, a 4G user will be provided 100 Mbps download speed, and once user consumes all the internet quota, the speed will be reduced or throttled to 128 kbps by PCRF with help of GX link. GY is between the online charging system, which is also called as OCS, and the P gateway. This is also a diameter link allowing online credit control for the service data flow based charging. In simple words, this is used for getting internet quota reserved and decrement on prepaid systems. Now, these blue color interfaces are based on the GTP. The first one is the S10, which is used between MME to MME. This is a control plane interface between MMEs, which is used for handover and context transfer. S11 is a link which connects MME to S gateway. This handles the functions such as bearer creation, deletion, paging coordination, and mobility management. The last one is S5, S8. The S5 interface provides user plane tunneling management between the S gateway and P gateway. This is based on the GTP protocol and is responsible for both control and user plane. S5 is internal to network, whereas S8 is used for roaming scenarios. For an example, a guy from USA goes to Japan. There is a S8 link which is created between a Japan S gateway and the USA P gateway. S1 contains two critical links, S1 MME and S1 U. S1 MME connects eNode B to MME and it is used for control plane signaling. S1 U is a user plane link. It interfaces and handles the S1 user plane data for each bearer between the eNode B and the S gateway. SGI link is used between P gateway and it's a breakout towards internet or IMS network. This is a highway for exit of a traffic all the way out from the LTE network. SGS. The SGS interface is used for connectivity between LTE MME to a CS network, which can be the 2G or 3G MSEs. Prior to VoLTE launch, this link was playing a very critical launch in 4G networks by enabling the CSFB function and SMS down the line for the users. I mean to say, a user before launch of VoLTE services can use 4G service for voice and SMS only with the help of this particular link. This diagram shows the LTE network architecture and links used in 4G network. Most of the control plane links are based on the diameter and GTP is used to carry the payload traffic. Now that completes our journey for LTE. Now we'll spend much more time on VoLTE, going into individual links in detail. This diagram shows the connectivity in 4G and IMS VoLTE network. We are going to understand each and every link in detail here. Diameter and SIP is the prominent protocol which is used in VoLTE IMS networks. We'll be starting with diameter links and we'll take this journey to the SIP links. IMS Control Plane link consists of SH, RO, CX, RX, SV, ISC, MG, MW, MI, MJ, MR, UT and ICI. Similarly, we are going to discuss the IMS User Plane links, which are GM, SIP, IZI. Let's start our journey and let's understand these links in detail. The first one is the RX link, which works on diameter protocol. This provides the connectivity between the PCRF and PCSCF. It is typically used for creation of an appropriate policy for a session for incoming or outgoing calls on network via PCRF. RX interface is a bridge between the IMS network and the packet core. The RX interface is used between the PCSCF and the PCRF for allowing a request for an appropriate policy for a session for setting up incoming and outgoing voice calls. This RX interface is used to control the establishment of any type of incoming or outgoing calls, and thereby it is used to authorize and control the resource usage in access networks. RX uses diameter protocol. You can find more details on RX interface under 3GPP specs 29214. So net RX link is used for every incoming and outgoing voice call. The second link is the CX, which is also based on the diameter. This gives the connectivity between the ICSCF or SCSCF towards HSS. It gives the connectivity of CSCF with HSS to get the user profile. It also supports in user registration and authentication. You can find more details on CX interface under 3GPP specs 29228. The CX interface is used between the I or SCSCF and HSS for downloading subscriber data. It enables IMS registration. It also helps in passing the subscriber data to SCSCF from the HSS. CX uses the diameter protocol. Typical messages on CX includes the UAR, MAR, SAR, which are used during the registration of IMS user in the network. For instance, ICSCF talks to HSS to get the subscriber detail information for user authentication. Similarly, SCSCF sends MAR request, which is multimedia authentication request, to HSS as part of initial IMS registration with IMS ACA related security information. The SCSCF also performs the SAR, which is server assignment request procedure, to the HSS to download the relevant user profile and register the VoLTE UE. The next one is the SH link, which is also based on the diameter. This is a link between the TAS and the HSS. TAS download the user profile from HSS and enable service for user with help of this link. The SH interface is used between the TAS and HSS to support exchange of user profile information such as service related information, user location information, or charging function information. It enables service and the subscriber related information to be passed from the HSS to the TAS. This is somehow equivalent to the location update between HSS and TAS. The SH uses diameter protocol. Typical messages in CX includes the UDR and UDA, which are used during registration of a IMS user in the network. The next one is the RO interface. The RO completes our journey of diameter links in the VoLTE network. This is a link between the TAS and the OCS. TAS communicates with the OCS, which is our prepaid billing and charging platform. The TAS communicates with OCS for online charging of our voice calls. For any voice call, the charging function needs to perform credit control before allowing a call to mature. With the help of RO interface, TAS communicate with OCS platform which perform online charging. RO interface also works on diameter protocol. For operator where RO interface is not supported on OCS or IN due to the old platforms, as an alternative, there is a SS7 based Camel protocol which can also be used between them, but that requires a map gateway which controls or converts the messages between SS7 to RO, which sits in between these two nodes. With Camel interface used in these typical deployments, VoLTE charging is done in a similar way which is done in a circuit core network with help of SS7. We are going to start our journey of SIP and SDP protocol from this slide. We can see the first link as a GM link. GM link is a connectivity between the UE and PCSCF. This enables the connectivity between the user and IMS network for registration, authentication, encryption, and session control. GM interface is the key for all user-based communication. The GM interface is used between the UE and the PCSCF for all purpose, such as like the incoming calls, the registrations, the outgoing calls, the SIP signalings, any type of communication between user to IMS network. For security reasons, the GM and MW interfaces are physically separate. Then is MW interface. This is a typical connectivity between CSCF to another CSCF. It could be in practical scenarios, it could be a connectivity between the PCSCF to SCSCF. The MW interface is used to connect CSCF node to another CSCF node in IMS network. Typically SBC host PCSCF which gets connected to the I or SCSCF via MW protocol. MW uses the SIP and SDP protocols for enabling these connectivities. MX interface. This is also used to give a connectivity between the CSCF and IBCF. It is used for interworking with the IMS network. I mean to say another IMS network. I mean to say if a call is going from my IMS network to another IMS network, now this particular link is going to be used. This is used by CSCF to send SIP messages from BGCF to the IBCF to other network. This is a MX interface which is used between CSCF and IBCF. It plays a vital role for the internetworking of a calls between two IMS networks. The next one is the MG link. This is a connectivity between the CSCF and MGCF. This enables the internetworking with circuit switch network to the CSCF. The MG interface is used to convey the SIP messages between the S and I CSCF to an MGCF for signaling purpose. This is used for exchanging signaling between the CSCF and media gateway for call which are going and coming towards the circuit core networks. This interface also works on SIP and SDP protocol defined in 3GPP TS 24.229 specs. Now next one is the MI interface. This is an interface between the CSCF and BGCF, serving CSCF to forward the SIP and SDP messages to the breakout gateway control function for the purpose of MGCF selection for interworking with the circuit switch networks. MI interface is also based on SIP, and this interface is used to exchange messages between the SCSCF and BGCF for internetworking with the PSTN. MJ link. This is a connectivity between the BGCF and MGCF. This allows the breakout gateway control function to exchange SIP SDP messages with the MGCF for the purpose of interworking with the circuit switch networks. This is another BGCF based interface between BGCF and the MGCF. The next one is the ISC link, which is really critical for us. This connects the SCSCF to the TAS. SCSCF interacts with the MMTEL supplementary services implemented on TAS. The ISC interface is another SIP-based connectivity defined under 3GPP TS 24.229. This enables connectivity between SCSCF and TAS, which is Telephony Application Server. This ISC interface interacts with the MMTEL supplementary services implemented on the TAS, where IMS Service Control Interface is used for requesting services from an TAS. The next one is the MR link. There are two links here you can see. The first one is the link between SCSCF to MRF. The another link is the TAS to MRF connectivity. Now, this allows the interaction of a media resource for specific supplementary services such as conference call. As you are aware, MRF deals with announcement and media related functionality such as transcoding, multi-party conferencing, the network announcement, tones, and so many different things related to the media. There are two interfaces providing the MRF connectivity to SCSCF and TAS. The first one is the MR interface between the MRF to the SCSCF, which is also called as the simple MR interface. The second one is MR apostrophe, which is a interface between the MRF and TAS. Now our SIP journey is complete. Let's go to see the another critical link, which is the UT link, which uses XCAP interface. This is a link between UE and TAS. It allows the configuration of a supplementary services specified for VoLTE service delivery to the handset. UT runs on XCAP protocol, which is a standard for Extensible Markup Language Configuration Access Protocol, also called as XML and the XCAP part. This UT interface is used between the user equipment and the TAS, and it allows the configuration of a supplementary services specified for VoLTE on the handset. The next critical link is the SV, which completes our journey of all the links for VoLTE. SV is a new special link which is introduced between MME to MSC for supporting the SRVCC functionality. Just like the 4G interfaces, this particular link also runs on the GTP v2 protocol. This is an overall diagram for VoLTE and LTE network with interface and link details. Please visit my website for free high resolution image of this diagram, which can be saved in your mobile or laptop and can be used as a quick reference. If you want to download this PPT or video, please visit my website. It's telecomtutorial.info. Hope this video presentation is useful for you. Please feel free to like, dislike, comment and share. Please subscribe to my YouTube